A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
Did it say I'm tired of fish, I'm tired of plankton?
For decades, humans recorded whale sounds without understanding them. Then artificial intelligence cracked the code and revealed something shocking. Whales have a real language with grammar, culture, and meaning. But when scientists finally decoded what whales were saying, they did not find friendly greetings. They found warnings. What have whales been telling us all along? And are we ready for the truth? Join us as we dive into the ocean's darkest secret. The message that shook science. The research boat floated in the dark water off the coast of Dominica. Below the surface, something ancient and enormous was listening. The marine biology team had no idea they were about to change everything humans believed about the ocean. For years, scientists had been recording sperm whale sounds. Thousands of hours of clicks, calls, and patterns stored in databases. Most researchers thought whales were just social animals making noise to find each other or navigate the deep. Nobody expected them to be saying anything that mattered to us. Then, artificial intelligence cracked the code. The AI found structure inside the whale sounds. Patterns that repeated, sequences that changed based on context, grammar that looked disturbingly familiar. The scientists realized they were looking at a real language. Not simple, not primitive, complex, and purposeful. They decided to test it. They used the AI to generate whale codas and played them back into the ocean through underwater speakers. If whales truly understood these sounds as language, they would respond. If not, nothing would happen. The whale appeared within minutes. It circled the boat. It vocalized back using the exact patterns the team had transmitted. Then, it added something new. More clicks, different rhythms. The whale was not just repeating sounds, it was answering. The first real conversation between humans and another species had just taken place. The scientists celebrated it first. Some cried, others laughed in disbelief. This was the breakthrough they had dreamed about for decades. Proof that whales were intelligent, communicative, and aware. But the celebration did not last long. As the AI continued analyzing the response and cross-referencing it with older recordings, something uncomfortable emerged. The patterns the whale had used were not friendly greetings. They matched sounds recorded near ships, drilling sites, and military sonar zones. Sounds that appeared during stress. Sounds that seemed to carry warnings or protests. One researcher stared at the data on her laptop screen and felt her stomach tighten. The AI had translated human noise into whale language and spoken it into the ocean. And the whale had responded not with curiosity or welcome, but with something that looked a lot like anger. The question nobody wanted to ask out loud finally surfaced. What if the whales were not trying to say hello? What if they were telling us to leave? The ancient clicks. We misunderstood. For over 50 years, scientists have been dropping microphones into the ocean and recording whale sounds. Sperm whales make a specific type of noise called codas. These are rapid sequences of clicks that sound like someone tapping on a desk. Click, 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 click. Pause. Click, click. The patterns repeat over and over. For decades, researchers assumed these sounds were simple. Maybe the whales were just echolocating, bouncing sound waves off objects to navigate the dark water. Maybe they were calling out to find their family members. Maybe the clicks meant nothing more than a dog barking or a bird chirping, just animal noise without real meaning. But they were always clues that something deeper was happening. Whales in different parts of the ocean made different patterns. A sperm whale family near the Caribbean used codas that sounded nothing like a family near Japan. If the sounds were just instinct or basic signals, why would they vary so much? Why would whales on opposite sides of the planet speak differently? Then scientists noticed something even stranger. Young whales did not know how to click properly when they were born. They had to learn. Researchers recorded baby whales making clumsy, broken patterns while swimming next to their mothers. Over months and years, the babies slowly improved. They practiced. They corrected themselves. Eventually, they sounded exactly like the adults around them. This was not instinct. This was teaching. This was culture. Some recordings captured even more unsettling details. When ships passed nearby, whale codas changed. The rhythms became faster. The pauses grew shorter. The clicks sounded sharper, more urgent. When military sonar blasted through the water, whales stopped clicking entirely or dove deeper and vanished. When oil drilling started in a new area, local whale pods began using codas that had never been recorded before. Scientists tried to ignore these patterns. It was easier to believe whales were just reacting to noise, not communicating about it. It was safer to assume the sounds carried no real message, but the data kept piling up year after year, recording after recording. Whales near busy shipping lanes use specific codas more often than whales in quiet zones. Whales that survived naval exercises seemed to share new click patterns with other pods they encountered later. Older whales who had lived through decades of human ocean activity produced sounds that younger whales from untouched areas did not recognize. The evidence was there the entire time. Researchers just were not ready to see it. Whales were not making random noise. They were not just calling out into the void, hoping for an answer. They were speaking with intention. They were warning each other. They were teaching their children. They were adapting their language to describe new threats. Threats that had names like propeller and sonar and drill. Humans had been listening to whale sounds for half a century and cataloging them like bird songs. Pretty noises from beautiful animals. But whales were not singing for human entertainment. They were talking to each other about survival, about danger, about the growing presence of a species that did not belong in their world but refused to leave. Every click had been a word. Every pause had been a breath. Every pattern had been a sentence. And for 50 years, humans had recorded it all without understanding a single thing the whales were actually saying. The ocean had been speaking. Humanity had been deaf. But now, the AI had learned to listen, and what it heard was not what anyone expected. AI unlocks the hidden structure. Human brains are amazing at some things, like recognizing faces, telling stories, and solving problems. But when it comes to analyzing thousands of hours of underwater clicks happening faster than the ear can separate them, humans hit a wall. Researchers spent decades listening to whale recordings and writing down what they heard, making charts, creating catalogs, and organizing the sounds into categories. But they could not see the full picture. There were too many sounds, too many variables, and too many patterns hiding inside other patterns. Then, artificial intelligence entered the game. Project CETI launched with a bold goal standing for Cetacean Translation Initiative, and the team included marine biologists, computer scientists, linguists, and engineers. They were not just trying to record whales anymore, but rather trying to decode an entire language, and they knew humans alone could not do it. The island of Dominica became the center of everything. A small Caribbean nation sitting in deep water where sperm whale families live year-round. The whales do not migrate away, but stay, raise their babies, hunt in the underwater canyons, and communicate constantly, making it the perfect natural laboratory. The CET team deployed hydrophones across the ocean floor with dozens of underwater microphones recording 24 hours a day, and they attached special tags to individual whales using suction cups. These tags recorded not just sound, but also depth, movement, and orientation, meaning every click could now be matched to a specific whale doing a specific action at a specific moment. The data poured in with hundreds of thousands of whale vocalizations and terabytes of information. More sound than any human could ever listen to in a lifetime, and this is where the AI became essential. Machine learning systems excel at finding patterns in chaos, and the same technology that helps computers recognize speech or translate languages got trained on whale codas. The AI listened to every recording, measured the timing between clicks down to the millisecond, and analyzed pitch, rhythm, and sequence while comparing codas across different whales, different families, and different situations. And then, it started seeing things. The AI discovered that whale codas were not random, but followed rules with certain click patterns always appearing in specific social situations, while other patterns showed up during hunting, and some codas only happened when whales greeted each other after being apart. The sounds were not just noise, but structured communication. The AI found something even more shocking in that whale language had building blocks, 4 basic elements that could be combined in different ways to create meaning. Just like human language uses vowels and consonants to build words, whales use timing, rhythm, tempo, and ornamentation to build codas. And changing one element changed the meaning. It was grammar, actual grammar. Whales were not just making calls, but constructing sentences and following linguistic rules that their children had to learn. The AI could predict what sound a whale would make next based on context, identify which family a whale belonged to just by listening to its dialect, and even detect when a whale made a mistake and corrected itself. Human ears had been too slow, and human brains had been too limited. but machines built by humans finally heard what the ocean had been saying all along. The whales had a language, a real language, with structure, culture, and meaning. And now, for the first time in history, humans had the tools to understand it. The question was no longer whether whales could communicate, but what they had been communicating about. While humans invaded their world, the AI was about to give them an answer, and it would not be comforting. Dialects, culture, and control. Language is not just about making sounds. It is about choosing which sounds to make and when to make them. And that requires something most people never think about, which is control. Whales do not click randomly or instinctively, like a heartbeat or a sneeze. They decide what to say, how to say it, and who to say it to. And this changes everything scientists thought they knew about ocean intelligence. The AI analysis revealed something stunning when it compared recordings from different whale families across the Caribbean, finding that each pod had its own dialect, its own unique way of building codas and arranging patterns. A grandmother whale and her daughters and granddaughters all spoke the same way, using the same rhythms and the same sequences. But a family living just 50 miles away sounded completely different. These were not genetic differences passed down through biology, but cultural differences passed down through teaching, meaning whales had invented their own regional languages the same way humans speak English in America and Spanish in Mexico. Young whales proved this beyond any doubt. Baby sperm whales are born without knowing how to speak properly, producing clumsy, broken clicks that sound nothing like adult language, and researchers recorded them practicing for years. The babies would swim close to their mothers and aunts, listening carefully and then trying to copy what they heard, often getting it wrong at first. The adults would repeat patterns slowly, almost like they were demonstrating, and the young whales would try again. This process took years, not days or weeks, showing that whale language is complicated enough to require childhood education. But the most disturbing discovery came when scientists tracked whales who left their birth families and joined new pods. Adult whales sometimes switch groups, either because their family died or because they chose to move. And when this happened, the AI caught something remarkable. The whales changed how they spoke, abandoning their birth dialect and learning the new group's patterns within months. They adapted their entire communication style to fit in with strangers. The AI found even more evidence of intentional communication. Whales use different codas depending on their audience, speaking one way to their own calves and another way to unrelated adults. They change their patterns based on mood, using slower rhythms when relaxed and faster ones when agitated or excited. They could choose to stay silent even when other whales were vocalizing nearby, proving they understood when not to speak. Most chilling of all, the AI detected moments when whales deliberately modified their language in real time. When a boat engine started nearby, some whales would switch to codas that carried farther through noisy water. When military sonar blasted through their habitat, they adjusted their clicking patterns or stopped entirely until the danger passed. This was not panic or confusion, but calculated response. Whales assessing a threat and choosing how to communicate about it. Language is power. The power to share knowledge, warn others, teach the young, and coordinate action. And whales have been wielding that power for millennia, while humans assumed they were just animals making pretty sounds. But the data told a different story, one where sperm whales controlled their communication with precision, passed down cultural knowledge through generations. They were not primitive creatures reacting to stimuli. They were intelligent beings using language as a tool, and that tool was about to be turned toward the species that had invaded their world. When humans spoke back, the scientific breakthrough had happened. Whales had a real language, and AI could decode it. But understanding a language and speaking it are two completely different things. Listening to whale codas did not mean humans could produce sounds that whales would recognize as meaningful. The CET team faced a choice that would change the relationship between humans and whales forever. They could keep listening passively like they had for 50 years, or they could try to speak. They chose to speak. The AI did not just analyze existing whale sounds. It learned the rules well enough to generate new ones, creating codas that had never been recorded before, but followed the grammatical structure the machine had discovered. This was not playback of real whale recordings, but original compositions, sentences in whale language written by artificial intelligence and spoken through underwater speakers. The ethical concerns were immediate and intense among the research team. What if speaking to whales changed their behavior in harmful ways? What if human-generated codas confused young whales learning their family dialect? What if the attempt at communication was misunderstood as a threat? And what if humanity was about to make first contact with another intelligent species without any plan for what would happen next? Some researchers argued they should wait years and study more before attempting communication, while others believed the discovery was too important to delay and that whales deserved to know humans were finally listening. The decision was made to proceed with extreme caution. The team would broadcast AI-generated codas near a well-studied whale pod in Dominica, using patterns that seemed neutral, based on context analysis, avoiding anything that appeared aggressive or distressing in the database. They would play short sequences, wait for responses, and stop immediately if the whales showed signs of confusion or agitation. The first experiment happened on a calm morning with clear water and good visibility. Hydrophones surrounded the area. Tags were attached to 3 adult whales in the pod, and cameras were ready to document everything. The team lowered the underwater speaker and transmitted the first AI-generated coda into the ocean, a simple greeting-like pattern that whales typically used when approaching each other peacefully. Then they waited in silence, barely breathing, wondering if they had just made the biggest mistake in marine biology history. The response came within 2 minutes. A massive female sperm whale, one of the matriarchs the team had been studying for years, appeared near the boat and began vocalizing. She was not using her normal codas, but producing the exact pattern the AI had just transmitted, repeating it 3 times as she circled closer. Then she stopped, floated motionless for several seconds, and clicked out a new sequence, one the AI immediately recognized as a pattern whales used to invite closer approach. The team transmitted another AI-generated coda, this time a slightly more complex pattern. The whale responded again, faster this time, using a variation of the pattern and adding elements the AI had documented in extended conversations between whales. 2 more whales joined her, both vocalizing, both clearly focused on the source of the sounds. The interaction continued for 18 minutes back and forth, with whales responding consistently to each transmission and even initiating new exchanges. This was not random, it was not coincidence, and it was not simple mimicry. The whales understood that the sounds coming from the speaker were communication attempts. They recognized the patterns as language, and they were choosing to respond. Humanity had just spoken in whale for the first time, and the whales had answered. But as the team reviewed the recordings that night, something unsettling emerged in the data. Several of the whale responses matched codas previously recorded near industrial ships and naval exercises. Sounds linked distress and warning contexts, making the researchers wonder if the whales were not greeting them at all, but telling them something humans were not ready to hear, the warning hidden in the data. The real breakthrough came when researchers stopped looking at whale language as random conversation and started mapping it against human activity. The AI had collected millions of whale codas organized by time, location, and context. And when scientists overlaid this data with shipping routes, naval exercises, and industrial operations, a disturbing pattern emerged that nobody could explain away as coincidence. Whales near busy shipping lanes use specific codas far more frequently than whales in quiet, undisturbed waters. And these were not social bonding calls or hunting coordination sounds, but sharp, urgent patterns with faster rhythms and shorter pauses. The AI flagged these as high-stress vocalizations, the kind of sounds that appeared when whales were agitated, threatened, or trying to get attention quickly. The most chilling discovery came from recordings near military sonar zones. Whales exposed to naval exercises produced codas that matched across different oceans and different decades, meaning whales separated by thousands of miles and years of time were using the same patterns to describe the same threat. This was not genetic instinct, but shared cultural knowledge. Information being passed between pods that had met and exchanged warnings about the dangerous sounds that could rupture their hearing and drive them to beach themselves in confusion. Researchers found evidence that these warning codas spread faster than whale migration patterns could explain. A pod near Hawaii would encounter naval sonar and produce specific distress patterns. Then months later, a pod near Japan that had never experienced military activity would use those exact same patterns when ships approached. The whales were not just reacting individually to threats. They were teaching each other, sharing survival information across vast distances through chance meetings and deliberate communication. Some codas appeared to function as boundary markers, sounds that whales produced when boats came too close or when human activity encroached on feeding or nursing grounds. The AI identified these as protest signals, vocalizations that increased in intensity and frequency the longer the intrusion continued. When boats ignored these sounds and stayed in the area, whale behavior shifted from vocal protest to physical avoidance. With entire pods abandoning traditional hunting zones they had used for generations, the decoded message was becoming impossible to deny. Whales were not making peaceful conversation while humans happened to be nearby. They were actively communicating about human presence as a threat category. They had words for propellers and drilling and sonar. They taught their children which sounds meant danger, and they shared warnings with strangers from distant oceans. The language humans had spent 50 years recording was not neutral observation of whale social life. It was documentation of an entire species trying to cope with invasion. Every coda near a ship, every pattern shift near industrial noise, every urgent call between mothers in cabs when boats approached. It was all part of the same message. The whales were not asking humans to visit or trying to make friends. They were setting boundaries, issuing warnings, and negotiating for space in an ocean that no longer felt like home. Orcas, resistance, and rapid evolution. While scientists were decoding sperm whale language in the Caribbean, something strange and violent was happening thousands of miles away off the coast of Europe. Orcas, the ocean's apex predators, had begun attacking boats in a behavior that seemed to come out of nowhere and spread like wildfire across entire populations. These were not accidental collisions or curious animals bumping into hulls. These were deliberate, coordinated strikes targeting the rudders of sailing vessels, biting and ramming until the boats were disabled and needed rescue. The attack started near the Strait of Gibraltar in 2020 when a small group of orcas began approaching yachts and systematically destroying their steering mechanisms. Sailors reported feeling powerful impacts from below, hearing crunching sounds as orca teeth tore into fiberglass and metal, and watching in shock as the intelligent animals worked together with clear purpose. At first, researchers thought it was isolated aggression from one or two individuals, but then the behavior spread. Within months, orcas that had never shown aggression toward boats began copying the attacks, and the behavior jumped between pods that had no direct contact with the original group. This was social learning happening in real time, with young orcas watching adults disable boats and then practicing the technique themselves. By 2023, hundreds of incidents had been recorded along the coasts of Spain, Portugal, and France, and the orcas showed no signs of stopping. What terrified researchers was not just the violence, but the communication surrounding it. Hydrophone recordings captured unique vocal signals being used during the attacks, specific calls that appeared nowhere else in the orca sound database. These were not hunting calls or socializing calls. They were something new, and they seemed to coordinate the attacks with different orcas, taking turns ramming the rudder, while others watched and waited. The calls would intensify when a rudder broke, almost like celebration or encouragement, and then the pod would move on to find another target. The contrast between orcas and sperm whales became impossible to ignore. Sperm whale language appeared stable across generations, with families teaching the same dialects for decades, and codas changing slowly, if at all, suggesting a culture built on tradition and careful transmission of knowledge. But orcas were different. Their communication was flexible and fast-changing, adapting to new situations within months instead of years. When they encountered a new threat or opportunity, they invented new behaviors and new signals to match, spreading innovation through their populations at a speed that looked almost human. Scientists began to wonder if they were witnessing the birth of a resistance language. Vocal signals designed specifically for interacting with human technology in hostile ways. The orcas were not just angry animals lashing out randomly. They were teaching each other how to fight back against boats and coordinating their attacks with communication that served a single clear purpose. Intelligence was responding to pressure in real time, evolving not biologically but culturally, and doing it faster than researchers could track. If sperm whales had been warning humans for decades through language nobody understood, orcas had stopped warning and started acting. Their message was not hidden in complex grammar or ancient dialects. It was written in shattered rudders and stranded sailboats. The ocean was not just speaking anymore. It was shouting, and the words were becoming impossible to ignore. Not a greeting, but a reckoning. For thousands of years, humans sailed across the ocean believing they were alone in their intelligence, that the creatures swimming beneath their ships were beautiful but mindless, driven only by instinct and survival. That comfortable delusion shattered the moment AI decoded whale language, and researchers realized the clicks and calls they had been recording for decades carried meaning, intention, and memory. Humanity was not alone in the ocean. It had never been alone, and the beings sharing the water had been watching human activity with growing alarm for generations. The evidence was undeniable. Now, whales possessed language with grammar, culture, and the ability to adapt and teach, while orcas demonstrated rapid social learning and coordinated responses to human threats. These were not simple animals reacting to stimuli, but intelligent minds processing information, making decisions, and communicating complex ideas to each other. The ocean had always been full of conversation. Humans had just been too arrogant or too deaf to listen, and now that they could finally hear the words, the message was not what anyone wanted it to be. The AI analysis of whale codas near human activity told a story of escalation and resistance. Patterns recorded near shipping lanes, oil rigs, and naval exercises carried urgency and tension that peaceful social codas did not contain. Whales were not singing about the beauty of the deep or calling lovingly to their children. In these moments, they were warning each other about propellers and sonar and drilling, teaching survival strategies to the young, and possibly coordinating avoidance behaviors across hundreds of miles of ocean. The language humans had finally learned to speak was a language of boundaries, threats, and resistance. The ethical weight of this discovery crushed down on every researcher involved. For 50 years, scientists had been passive observers, recording sounds and publishing papers while assuming whales had no idea they were being studied. But if whales understood that boats meant humans, and if they associated humans with noise, collisions, entanglement, and habitat destruction, then every research vessel that approached a pod was not an invisible observer, but an intruder. Whales knew humans were there. They had always known, and the decoded language suggested they were not pleased about it. The orca attacks off Europe took on new meaning in this context, no longer random aggression, but a logical extension of intelligence under pressure. If communication could spread warnings, it could also spread tactics for fighting back, and orcas had decided that disabling boats was an effective response to decades of overfishing, pollution, and noise. They were not mindless killers. They were strategic thinkers adapting their culture to survive in an ocean increasingly hostile to their existence. Humanity now faced a question it had never seriously considered before. What happens when another intelligent species decides humans have gone too far? The ocean was not empty wilderness waiting to be explored and exploited. It was someone else's home, and the residents had been telling humans to leave for years in a language nobody bothered to learn. Now the translation was complete, and the message was clear. This was not a greeting or an invitation to friendship. This was a reckoning. The only question left was whether humans would listen before the ocean stopped talking and started acting with the same violence orcas had already demonstrated. The whales had given their warning, and time was running out to respond. If you enjoyed this, like and subscribe for more.